Microservices, also known as microservice architecture, is a software development method that combines an organizational and architectural approach to software development. The goal of microservices is to have small and independent single-function services that communicate over well-defined APIs. These services are owned by small, self-contained teams. Microservice architecture helps build more resilient and scalable applications. Applications are built as a set of independent, well-defined and specific services. Each service can be easily scaled up, updated, deployed, and operated without affecting other services. Services communicate over APIs, so teams are not forced to use the same technology stack for all services. They are encouraged to use the best possible tools to solve technological challenges. Let's compare monolithic and microservices architecture. In monolithic applications, all processes run as a single service. They are tightly coupled. If one process experiences an increase in demand, the entire architecture must be scaled. Also, there is a higher risk of failure due to the tightly coupled processes. In a microservices architecture, applications are built as a set of independent services that perform a single function. Services communicate via well-defined interface using lightweight APIs. Each service is built for specific business capability and runs independently. This allows services to be updated, deployed, and scaled to meet each service-specific requirements. Every service inside the microservices architecture is built as an autonomous function. Each can be developed, deployed, operated, and scaled without affecting other services. Services communicate via well-defined APIs, and none of the code is shared between services. Each service of the application is designed to solve a specific business problem. If any service becomes complex over time, it can be broken into smaller, more independent services. Microservice architecture encourages an organization of small, independent teams that are responsible for each service. Teams' responsibility and scope of their work is well defined and understood. This enables teams to work faster and independently from each other, consequently shortening the development lifecycle. Each service can be independently scaled to meet the spikes in demand. This helps simplify infrastructure sizing, accurately measure feature cost, and maintain service availability. Microservices enable continuous integration and continuous delivery. New features can be tested and implemented faster and simpler, without affecting the whole application. If something is not right, features can be rolled back. Under the microservices architecture approach, teams are encouraged to use the best tools to solve their specific problems. Instead of using complex, heavy, and over-engineered tools, teams can use lightweight and specialized tools to solve technological challenges. Applications are divided into small and well-defined services. They can be used in more than one situation. New features can be built by using existing, well-defined services, enabling code reusability. Service independence helps an application's resistance to failure. With monolithic architecture, a single component can cause the entire application to fail. In microservices, this is not the case. If any service fails, the other services will continue to work. This means that application remains functional regardless of single service failure. Amazon Elastic Container Service is a highly scalable, high-performance container management service that supports Docker containers. It allows you to easily run applications or a managed cluster of Amazon EC2 instances. Aws Lambda is a service designed for companies that want to build and run apps and services in the cloud without thinking about servers. With Lambda, virtually any application or backend service can be run with zero administration. Just upload your code and Lambda takes care of everything required to run and scale your application's code with high availability.